But for, so we have also a lot of proprietary cloud systems, like AWS is the main one, Google App Engine, Dropbox, and then a lot of like, GitHub, et cetera, et cetera. So we have a lot of proprietary cloud providers. But there's no defined idea of what an open cloud system would look like. We have some ideas like a BitTorrent sync is one of them. BitTorrent itself, I think, is an open cloud system, sort of. But it's not like entirely clear how that works. So this open cloud project is one idea of how that might work. And one thing I want to distinguish is the idea of a personal cloud versus an open cloud. So BitTorrent sync is a great idea, but in that system, it's basically a system where you can like host your own Dropbox for yourself. But the problem there is you have to basically host it yourself. And to put in cloud software is that you don't want to do the hosting. So the personal cloud is like you host it yourself. And the open cloud that I'll talk about today is going to be more like a marketplace for cloud services. The other motivation that Bitcoin, in my view, is. So I view Bitcoin as an enabler for the open cloud system. And the reason is that there's two major factors. So the way I envision an open cloud system is a marketplace for buying and selling cloud services. And to distinguish that from the current system, you have like AWS, for example, where anyone can go to aws.com, sign up, and purchase cloud services. But you and I can't go on there and sell our services. So it's a one-sided marketplace where anyone can buy, but not anyone can go on there to sell. And so the open cloud system that I'm envisioning is basically just like that, where anyone can buy, but also anyone can come in and sell, is the key distinction. And if you think about why that hasn't happened yet, one of the reasons might be that before we had no universal payment system. We have a lot of proprietary payment systems like, Swift, ACH, PayPal, Amazon, payments, but they're all proprietary, and so they're not intercompatible. And if you're trying to build a marketplace, you might have to pick, okay, this marketplace is going to be based on Stripe payments, and at that point, it kind of jives with the idea of open source software because now you're not, you picked a proprietary payments. And the other problem also is that spam becomes a big problem in any open cloud system. Because what you're selling, if you're selling storage, it costs money to provide storage. And if someone asks for the storage, if you expend resources to provide it, and they don't pay, then that's a huge cost to you. Whereas conversely, if you pay for storage and you don't get it, that's a cost to you. So Bitcoin provides a scarce token, which we'll see later that can be used to kind of prevent spam attacks. So that's the two major factors. And then the minor factor also is, again, open clouds should use kind of an open payment system. They have the philosophical reason, and that's more of a minor reason. The other motivation is, if it works, that'd be pretty cool. But there's actually some caveats. Is it actually a good idea? And I would argue that everyone kind of accepts that open source software is a good idea. I think Linux is great, Firefox is great. And open cloud is not as good of an idea as open source software. And the reason is that cloud services, the lock-in usually is not that bad. You can go from AWS and take all the data out pretty easily, because people are kind of hyper-aware of this lock-in effect. And also, Windows and IE were widely disliked, whereas AWS, Dropbox, people mostly like them. And also, they're not too expensive. So whether or not this is a good idea actually is kind of up for question. But I think if it does work, it's cool enough that it's worth trying. Anyways, all right. So if we're going to provide cloud services, where do we start? Let's look at all the services Amazon provides, and let's just pick one at random. Storage. So we do storage. And so the first thing you might think is, it's going to be a distributed Dropbox. And it's kind of like the initial vision. Basically, you have a P2P network, and you have server nodes that enter freely and exit freely. So, I have my laptop, I connect for 8 hours to the network. I provide storage for 8 hours, then I disconnect. And then, someone's a desktop computer is always connected, but maybe it goes down once a week because they do maintenance, they restart it. And you have Amazon who connects, 24/7, you have really high quality service. And then the P2P network kind of figures out how to balance, low balance, and keep running copies here, running copies there. And that's a great long-term vision, and that's probably how the system will work in the long run. But it's very difficult in the short run, and it suffers from the 80/20 problem, which is that you'll spend 80% of your time figuring out how to deal with flaky servers. What do you do when a server goes down, when data is lost? And maybe 20% of your time is providing a good user interface, like a usable user interface, and the actual service itself. And the other problem is that initially there'll be a lot of flaky servers of guys just trying it out, let me try it out. If I can get some money by selling my laptop space, and we'll get 2 cents a day, and you'll turn it off. And you'll get a lot of it initially, and users will connect to the network, hosting the data. They'll get bad service. They'll say, oh, it's a stupid system. It's not hosting my data. I keep losing my data. And they'll blame the service. So this was the initial vision. The revised vision is run your own Dropbox. And this is kind of like step one to build towards the long-term vision. So step one is basically let anyone run their own file hosting service. So make it really easy to basically download a binary, put in a command line, run the binary on this board, and start hosting service. And that's kind of the short-term vision. And so the product will be, it's a command line interface. The kind of unique feature of this kind of file sync system is a command line interface where you can say, oh, I want to sync these files in this folder, and I want to, pay Bitcoin. That's kind of how we'll work initially. And then step two, you can't see that there, but step two is to build towards the long-term vision I described earlier. Let's see. Okay, so let's get into the technical details. Let's look at something interesting. So the system is basically going to be, again, it's going to be a marketplace for cloud services. Anyone can sell or buy any cloud service, storage in this case. And so what you need is an RPC protocol, which says, you're the server, I'm the client. Please perform some service for me. I'll pay you for it. And then the client, the server responds, spin, 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 and it responds, okay, I completed the service. Please pay me now. And the server says, okay, I'm going to pay you. And that's the basic. So that's the basic way it works. And again, as I mentioned earlier, the problem with the system is that when the server provides a service, it's costing them money. And it's when the client is paying the server, that costs them money. So you have expensive. Basically, when there's a bad actor, it's expensive. Compared to if you go to NewYorkTimes.com, you spend you do a lot of GET requests. It's not going to be that bad for 1,000 or 1,000 GET requests. There's DDoS gets 1 million requests will be bad, but on the order of like tens of thousands of bad requests per minute or per hour is not going to be that expensive. So, but then I think an OpenCloud system is very different. So you want to prevent spam attacks. And the way that works is any request will be signed by a public-private key pair, it's called your OpenCloud ID. And associated WAF, and in association with that, you'll have a sample request right here. Yeah, so that's your OpenCloud ID right there. It's this long string. And then you sign the entire request with a signature. And also you say, I control the address for these coins. And here's a signature proving that. And these coins might contain, let's say, 1 BTC or 2 BTC or some number of Bitcoins. And that basically means that you hold in escrow, let's say, 2 Bitcoins, and no one can. So if you send a lot of spam requests, the server will say, oh, whoever's, this identity is bad, I'm going to block this identity. And at that point, the attacker will have to generate a new identity. But you remember that they use this Bitcoin address as their proof of identity, so to speak. And so they'll have to find a new one to use. And that'll just make it a little bit more expensive to do attacks, and therefore, ideally prevent spam. So that's the idea behind that.
How much more expensive? I mean, when you say preventive, how much more do you prevent, and how expensive can it get first?
You can configure it. So the way I have the server set up right now, basically, it'll deny requests from anyone who has less than, I think, 1 testnet Bitcoins in escrow. If you get a lot of spam attacks, you might say, you must be sure that you have one testnet Bitcoin in escrow. And at that point, you can make it more expensive to spam. So it's configured. Initially, yeah, so it's configured. And at that point, obviously, you can move the Bitcoins, so you can set a confirmation window of, say, one testnet Bitcoin that has been sitting in the address for 6 confirmations. So say, move around. That kind of creates problems. And then, so the rest of the protocol, basically, you say a service that you want to call, a method, so like storage.put, storage.get, and then the arguments. And then,
Is that a question?
Yeah.
How do you compute the coin SIGs? Because the coin's address, it has the hash of the public key.
Oh, so the client.
Don't you need to also prove that you have to actually pass in the public key and then?
It's a Bitcoin V call. So you call Bitcoin V and say, oh, here's a signature, verify the signature. Actually, I'm not sure how to do the Bitcoin Vs, but the Bitcoin V requires the signature, the message, and the address. So I think it has, again, I'm not sure, but it has some way of kind of figuring out whether the signature is valid or not. Let's see. Okay, so the server basically, it provides a number of services. Storage is securely the first one. And then for every kind of OpenCloud ID, again, this thing right here, it maintains the associated Bitcoin addresses and then also paying bounds. So let's say I provide you an hour of storage. It'll say, okay, now you owe me 1 cent, another hour, 2 cents, 3 cents, 4 cents, and so on. And the server can be configured to basically allow a max balance. Say I'll provide you, $10 of services, and at that point, you have to pay me. Or I'll front you like $10 of service, and then you have to pay me. And at some point, you have to say, okay, now it's time to pay for these services. And then, okay, and then the client kind of sends a request. Let's do actually some demo, and kind of want to even bigger. Okay, there we go. Bring up my cheat sheet. What if you don't have to see? Okay, so we're going to run this server on port 9443. We're going to store data in our home directory, .OpenCloud server 1. We're going to allow users a maximum balance of 0.1 BTC. So that basically means we'll provide 1.1 BTC of services to them before we retire payment. And then this is going to be for a calculator service. So basically, you can, as a client, say, oh, add these numbers for me. And then the server says, okay, they're added, and it charges some amount of money for that. So for each calculation, it's going to charge 0.01 BTC. So to add 1 plus 1, it'll say, okay, you got to pay 0.01 BTC to do that. Let's make it more, let's make it 0.01. Yeah, that's what it is. Again, it's an example. Obviously, you can have this in real life.
But it's high quality. It's a high quality.
Yeah, it adds very accurately. But it's good to get it. It's a demo too to show how good I get. Okay, there we go. So it's listening on port 9. Okay, so now if we go over to the client, it'll be this.
Please close the door.
This guy here. Actually, it's minimize for now. Okay, so that OpenCloud client, and we're just gonna find out how much it costs to do our agents. We're gonna add 1 and 1 plus 2, and we're gonna ask, the server, okay, how much does that cost? Calculate that. So the thing, it costs per BTC. Okay, great. Actually, let's just as a kind of proof of concept. Let's say there's a competitor running who's running a second server, and they're going to undercut us. So here's our competitor. Come on, looking for. Process. So we're going to run, we're going to charge only 0.02 BTC. It's going to be less. We're going to make money that way by make up the volume. We're looking at port 9445. And so we're going to shop around, say, you know, a better price. All right, great, that's cheaper. All right, so we're going to go to the server to kind of compute our computation. So the call is very simple. We're going to say call the calculation service, adding 1 and 2 on the server 9445, and then we're going to defer payment of 0.03 BTC. So basically, we're promising to pay after the service is completed. So send that off. Equals. And it says, oh, it's 3, and 1 plus 2 is indeed 3, so the server made good on its promise to calculate the computation for us. So now we say, okay, well, the server paid us, or included service. Let's see how much we owe it. So we get that payment balance, and again the address, and that should be all. Yeah, we get the payment balance, and the server says we owe it 0.03 BTC. And it's going to front of 0.1 BTC of services before we actually have to pay. So we'll do, 2 more calls. And now our balance is 0.09 BTC. I think one more it'll let us do. And now it's going to say, please pay before continuing. So saying, okay, we fronted you to 0.1 BTC of services. Now that we've reached 0.12 BTC that you owe us, we're going to require payment before continuing. So it says, no, I won't do it for you. I require payment. And so at this point we'll say, okay, fine, sounds good. I'm going to send, let's see, these Bitcoins over to the server there. And so we get our payment balance now. You'll see that it's a balance of 0, and again, we're probably going to put over BTC. So that's basically, so that's a very simple computation service. It's kind of like analogous to it's kind of analogous to like EC2, that kind of thing, for a very basic use case. But not very interesting because you can just cut the numbers like out there. So actually what we're going to do now is a storage service, which is a little bit more interesting. I'm going to kill this server here. Let's see, restart it. Where's my cheat sheet? Let's see. Yeah, I think I should run the exact same server. We're going to run the same server. We don't need the calculations anymore. And we're going to run a new directory. Server 4. Okay, so this server, we're going to actually try to store some files on here. Let's see. Okay, so first we need a file source. We're going to echo hello world into some file.txt. Echo. Okay, great. Yeah. So, and now we'll just cap that file. And then call store.put to the local server, which is running on 9.4.3. So I think that okay, great. So what we're returning here is basically the way it's set up is every file corresponds is like a blob, and so this is a blob ID. And you'll notice here is this server is basically like every 10 seconds it'll come up and say, oh, 12 bytes used by this ID, so increment the cost by whatever we're charging for storage. In this case is, I guess, some small amount for 12 bytes. And again, so we can call the server and get our balance, and we'll see that, okay, the server tells us, okay, we owe this amount of money. And it'll increment that every once in a while to, as we use more and more storage. And so similar to how once we go over the balance, it'll stop accepting requests from us. So we're going to take a while. So let's actually have this sort of big file for us. So I have a big file about that. It's as you can see, it's 100 kilobytes, which is not that big, but it's big for our purposes. And I'm going to have it store that for us. So here it goes. And once at the balance, will run much more quickly now. Once it does this 10-second cycle, it'll say, okay, now we're going to charge you 1 BTC for every 10 seconds that you store this file. Which again, obviously you can configure the parameters via flags. And so it sort of says, okay, you owe us 1 BTC now, and now it's 2 BTC now. And so if you want to get the file, please pay us. So let's see if I have that many testnet Bitcoins, I can actually get the file back. Let's find out. So we're going to send the payment that the server is requesting. Actually, we'll send a lot more because it's running up very quickly. So I'll send that address. And now our balance should be 0. And so now we can actually get the file. So about the so 256, yeah. So we're going to call store.get on that file. Well, now we run the balance again, but okay, so the server says, oh, you got to pay us some Bitcoins. So it's give the server's money, and then now we'll get the file. There's the file. It's set binary form. But that's the basic way it works. And so the thing you can notice here is that this is just a server and a client interacting. So actually, there's not that much to it. But the idea is, it's very simple to run the server and run your own Dropbox. Like at this point, all I need to do is, well, make the client more complete, obviously, but you just publish that IP address, and anyone in here in this room could say, oh, I want to post my files on Marcel's computer. Here I go, and then you're kind of off your races. And similarly, there's a standard client that can say, oh, please store this file. And so the hope is that first, I'll be the only one running the server, and in an ideal world, people will say, oh, Marcel's making all this money posting these files. He's making some small amount of money. Let me, copy what he's doing, and maybe, undercut it by 10%. And at that point, as more and more servers and clients kind of build up, the hope or idea would be that then you can build a P2P network that kind of distributes and this replication system and stuff like that. But the early prototype is actually just kind of run your own Dropbox model. And the idea there is to kind of make incremental steps towards an open cloud and not deal with the really complicated problems of PGP, spam, simple tax, load balancing kind of stuff. So yeah, that's the whole idea. So for anyone who's not familiar, microclearing channels basically is an off-blockchain protocol where I say, Yuri, let's set up a channel and I'll pay you by the millisecond or by the second, and I'm going to increment how much you're paying. It's kind of a trustless model for competition. So that does seem useful in the long run. In the short run, again, because I'm going with the model of individuals running their own servers, it's actually not that necessary. Because I guess there are two reasons why it's not necessary. The first is that because it's kind of a trusted model initially, you kind of connect to a specific server or a specific set of servers, and you trust that they'll provide the service to some degree, or they'll trust that and they trust that your clients will provide the payment. So that's the first reason. And the other reason is that the way it's metered with the balances is you maintain a balance and you pay every 10 BTC or something. So you don't have the problem of huge minor fees, eating into your profits or eating into your cost, because you only submit payment once every day or once every month. So that's the reason why the short run is not needed, but in the long run, I think that's probably the way to go. If you can find a way to figure out some of the technical issues.
So if I have really big files and I have to charge this, how do I figure out my bandwidth costs plus storage costs? How does one? Also, what if I have a really nice server and I'd like to charge a higher price because I have better capacity on storage and bandwidth or even security?
Mm-hmm.
How do I? How can this sort of protocol allow me to sort of expose that as a way to attach value on pricing?
Yeah, let's see. So
in a provable sense.
Yeah, it's not provable. Basically, the model here is, so basically, as some background, there's the idea of proof of work in Bitcoin is you do a bunch of hashes, you do 10 minutes of hashing, and you can verify in 1 second if someone did that or not. And similarly, so that idea works very well, and it's appealing to have the idea of proof of resource, where you say, prove to the entire world that I stored a file for Tariq. That'd be great. And someone might figure out a way to do that. I actually haven't. So basically in this system, you cannot prove to the entire world that I stored a file for Tariq. It's more it's two reasons now. It's a one-on-one relationship versus a to-the-world relationship. And so me and Tariq establish a relationship where we know that he knows that I stored a file, and I know that he's paid for it. That's the short-run model. In the long run, you can have a kind of a distributed reputation system where I say to the world, Tariq has paid me 1 million times. He's great. And I'll spread that information to the world. And in the long run, it's hype. So in the long run, that's kind of how you would provide proof of an analog proof of resource, where you tell the world that Tariq is getting paid very well, or conversely, you tell the world that I provide a very good service. And then people will compare my reviews to their own experience to kind of do a linear algebra kind of sum kind of thing. We say, Tariq has, he's got good information on who provides the services. So that's the long run view. In the short run, though, again, this is a very technical approach. So in the short run, I'm going to run a server and I'll publish statistics, and people can say, okay, I do these statistics. For the bandwidth, so it's metered right now only by storage costs, but you can also meter by transmission. And that would be pretty easy to have on the current protocol. You just say, for every kilobyte of downloads, add 1 MBTC or 1 Stocher or whatever.
So you don't think MadeSafe has proof of resource figured out?
I don't know. To be honest, I don't know. Actually, I don't know how that would work. Maybe they have. I don't know. If anyone knows how it works, then. Does anyone know how it works? Okay. If you do, I'd actually like to know, because I guess the problem I see with that model the reason I thought it was I can figure out a way to do it is you can prove that a file is stored in one place, but I don't say you can prove that it's stored in multiple places. And also you can prove that, and also I don't say you can prove that a file has been transmitted over the internet. Because unless like as far as I know, unless like you tap the copper fiber going between two places and monitor it, you cannot verify that. And unless like you're the person doing that, you can't tell if the person doing that is actually lying, as far as I know. Then again, before Bitcoin, when you had to solve consensus, so maybe it's possible, but I don't know how MidState does it.
So it seems like what you've actually got here, arguably, are expiring options for compute services. So you're saying, look, if you give me this amount of money, and you haven't put it explicitly here, but in a certain reasonable amount of time, this is how much it costs. If you try tomorrow, maybe it'll be more. Mm-hmm. So there's sort of a competition between you want to be able to negotiate a service, especially with the storage, where it's not going to suddenly go up overnight, mm-hmm. or if it does, you can react to it. It's really sort of a contract negotiation.
It's like a hostage situation where I hold the data hostage and you store it, and now the price is twice as much as it was yesterday.
Which can go a lot into this balancing. Maybe you try the transmission balancing. Maybe you charge a thousandth of a penny, and it turns out that doesn't really stop spam. So you increase it to a tenth of a penny, and that kills the service. So you want to put it back down again. So you want to have that ability to be dynamic with the pricing, and at the same time not jerk around the service. So it seems to some extent putting time limits on the various contracts, options, whatever, is almost as important as the amount. And this is getting, it's modeled as a financial transaction, but I guess I'm pointing out that it's to some extent a time
in a sense that there might be higher demand that
being, or maybe that's a way of looking at the product, is that it's a...
Is it the demand higher in the afternoon, so you might charge higher prices than kind of like a surge pricing model?
Right, exactly, and especially to the extent it's bubbled up to the, you've got markets and auctions where you're saying, okay, service N index, I've got 5 pages worth of, addition calculations for various spreadsheets or whatever. How much is this going to run me? And you can get back the price that the latest competitor wants at that time. Obviously, that's looking far out in the future, but
the problem with storage, it's also that it takes place over a long period. The computation, it happens in an instant essentially. For the most part, it was the storage takes place over a long period of time, and so things tend to change a lot over that period of time. Make a lot of incoming demands and such. Right. Yeah, in this model, you trust the server to price fairly. I guess how I would say it initially. So you trust drop-offs to price $10 a month. You kind of trust that. You trust Amazon subscriptions to charging X dollars per kilobyte, X dollars per bandwidth, and you kind of accept that that's what happens. So this is the same system, but I guess it's the same system here in the short run. I'm running my server, and people will trust that I'm running it fairly because it was a proof of concept server. It's one that's more advanced, but you might say I could do a more advanced model that's priced in a more advanced way that has lower prices, but has a certain pricing feature also. People might try it out and say, this sort of works, it does not work. And in the short run, I think how I do is you kind of have different servers with different kind of pricing models, and you kind of pick the one that you like, and you experience their pricing model and see, through your own experience, see if you like it or not, is in the short run. And so if they jack the price a lot, you may say, I'm going to use that again. Or if they price it unfairly, or if you do unfair surge pricing, you might have to use it again.
So the mechanism is pretty much compatible with whatever pricing model.
Yeah, basically on the server side, you can do any pricing model you want, but people might not like it. I guess that's how I would say it works. And to some degree, there's because it's a black box what the server is doing, to some degree, you can trust that they're doing the correct thing or a fair thing, and you kind of compare your experiences. In the long run, there's a reputation system that you could build out, but that's kind of, for reasons I described, it's kind of more of a long run thing.
How far are you along in terms of the project? What help would you like to have in terms of that's a Bitcoin Devs contributed? Folks are looking to participate in. How soon can we, play with it as maybe a group here?
Let's see. If you want to put, the source code is on GitHub actually. Let me put up the URL. Let's see if I can make this really big. It's really big. Really big. So it's posted there. Let's see. You can definitely run it. And actually, if anyone wants to try it out and like post some stuff on my computer later on, just come out to talk to me. If you have test at Bitcoins, then that'll work. As far as contributions, as far as I would say it's a very early prototype. It posts files for you and it blocks payment, and it kind of like prevents spam attacks using the system I described. As far as help, pretty much anything. Yeah. If anyone wants to contribute, just talk to me. I'm more than happy to accept contributions. It's an open source project, so yeah. Okay.
Can you talk a little bit about your thoughts on like advertisement of services? Like, like I would assume that there's going to be a peer-to-peer system that's going to be broadcasting offers of compute or storage or whatever, calc, as you say.
Yeah.
And then there's going to be offers of, hey, I need somebody to run something. Maybe I have some code in GitHub. I'm like, I need somebody to calculate this code on GitHub. I need some bit on it or something.
Basically, okay, yeah. So the question is, I guess, so like step one, I guess, is I'll put up a society like OpenCloud.org or whatever. And I'll say, run this command line to store your files, and I'll have like my server address in there. Once the service gains popularity, I'll let me email this thing. If you want to add your URL here, contact me. That's kind of the short run. You can also very easily imagine like, whereas here I was doing OpenCloud store.get, or people might do that one. So here I had like the call to quote of price combination. You can very easily imagine a list of like these 5 servers, and then call the best one. So once like more people start trying services, you'll put in you'll put in like the auto select the lowest price, or auto select the lowest price from the whitelist of people I trust. And it kind of builds up from there. Like for example, the whitelist. Now you have like a whitelist of like I trust your whitelist. Might be like the next steps. Like you're gonna like curate a whitelist for me. And then the very long run is like obviously like but it's like a peer-to-peer network that you expect create a network on the fly programmatically. But the thing is, it might be kind of like baby steps towards that. So first is like I'm your own server, then like my friends and people who kind of want to, and then like people kind of maintain whitelists. And then using the constant creator list and quoting, you kind of like get the lowest price of your whitelist. That's kind of how I do that.
Have you considered, it wouldn't really work for storage, but for pure computation, allowing someone to just bid on the work that they want done and having a consensus, like having the network try to solve the problem, and then maybe the group of people who come up with the same answer, that gets selected and they get maybe a share of, or maybe the first person to get the answer gets it, or some other model besides just a single server processing?
Oh, I just see like I have like this computation to do it, and like I want like 5 people to do it, and if all the people who do it get paid, essentially. Yeah, that's an interesting model. Because there's sort of 2 parts to the question. One is because I'm having like the servers are kind of like a static entity, and people like talk to the servers. And so what you're describing is like the clients like say, oh, at some point I want this done. Servers, please talk to me. And like if you talk to me, I'll give you some work to do. That's an interesting model. I guess I did it the way as the server listening model, just because, like, you think of the word like Walmart exists and people go to Walmart. It's less common for Walmart to come to you, I guess, although Amazon can deliver it pretty quickly. But again, so that's kind of like, I feel like the more common case is like you're selling something and you want people to come to you. That's more common case. For the distributed computation, that ideally you wouldn't actually have that, and the reason is that if you're doing something 5 times, it's 5 times more expensive. So like, and you do kind of do that in like a PHP network, you might kind of want to verify someone's work versus do it correctly. It's part of why the computation is or so it's why the storage works, because storage is very easy to verify. You just you hash the file, match up the hashes, and see if they match up. Or you hash plus assault to make sure you're actually not storing the file. Whereas computation, like you don't know if they got the right answer with current cryptography. In the future, that might change. Although, if you're doing like something like crazy, like cryptographic computation, then you might be adding a lot to your computation cost anyway. So that might double your cost because you're doing like some verifiables or knowledge, whatever. And so that might also be uncountable. Which again is why my hope is that go to plug the limiting the whitelist and then building out from there. Model will limit the need for like redundant computation, and therefore kind of not make people waste time and 5 times computation that they actually need to. But that being said, but you might do that on just like verify, but I feel like the costs are kind of maybe not the best idea. I don't know.
It's like there's computations that you need to trust, and there's computations you don't need to trust.
In what sense?
Well, I mean, like Ethereum, for example, is going to, you know, in theory, run certain types of code,
Mhm.
right? But then there's also code you could run that you don't really. I just need somebody to go pull down a web page, like go scrape a website.
Yeah, I guess it appears like even for that one, like, so like let's say like I'm running like a binary block. Like one idea is, or one idea you could use like use Docker, or use like a virtual machine, and like everyone hands you a binary block, you execute it, and then you return like the result. And the fear might be that like someone might just like return a random result, like a random number.
Right.
Which is why like you kind of need to know whether or not to like actually run the script. And so maybe there's some ways to do using encryption, or more, et cetera. But I guess barring that, you just kind of trust the data, or you deliver the machine, trust the data. So the first two times you might verify, like, oh, like have two guys do it and see if like they can or do spot checks or things like that.